All right. Well, let me go ahead and get started. Hopefully everybody can hear me. If one or two of you would do a quick chat window, let me know that my audio is working. That would be great. Great. Thanks, Bennett. I don't get a sound meter on this, so I should find a plug-in or something for that. Great, Colleen. I'm glad it's working for you. I know we've had trouble in the past. Well, I want to just say thanks for joining me this fine Tuesday in the middle of July. We're going to talk about reliability and statistical process control. And I suppose what could be more exciting than that? But hopefully I'll convince you that it is pretty important and it's something that we really should pay attention to as reliability engineers. I'm going to leave this screen up for just a moment. You can find the slides over to the right. I think there, let's see if I can get my cursor to show. There it is. Just to the right of the rotating slides, there's a downloads part where you can find the slides. And also a little bit lower than that, there's a set of links. So if you want to stay in touch with me or follow me on some other activities or whatever, that'd be great. The webinar list is just about 450 people now, and monthly we list all kinds of webinars, not just this one, but I think last time we had about 8 or 10 different webinars from different organizations on a whole wide range of topics. So you get an email just once a month that shows what's coming up in the next month, at least the ones that we know about. So if there's anything on that list that if you do get it, let me know if there's anything missing in any other great webinars out there. We'll see if we can add it on a regular rotation to that list. The other thing I put on here is the CRE Prep site, and that's a link to creprep.wordpress.com, which is a site I started a few years ago, and a number of authors have added short tutorials on the certified reliability engineering body of knowledge. And the information is intended for those that are preparing for the CRE exam through ASQ. But it's also kind of a nice weekly reminder of all kinds of different tasks and techniques and things that we do as reliability professionals. So it may remind you of some stuff or reinforce what you already know. So that's ongoing. And since we're talking about SPC, there's a whole slew of SPC and capability analysis type tutorials on that site. And so if you really want to get into the basics of this stuff, that's where you will be able to find a whole, probably a dozen or more short tutorials on different aspects of what we're talking about. But so Chris, you're not getting any sound, no sound. So I got word from a few people that it's working. So let me do. So most often, if somebody's having trouble with sound, and this is kind of ironic that I suggested I should probably put it in the notes someplace, is just log in again, and that usually takes care of it. But the other one is to check the audio settings, making sure that your headset is working. But if you could hear the sound of the music earlier, then it should just be working. Yeah, so anyway, hopefully it's working for most of you, and I'm getting some acknowledgement, so I think we're ready to get started. So let me pull up the slide set here. Thanks, Myron. Yvette, so clicked on the audio and cycled on off. Great, good advice. I appreciate that. Thanks for helping. All right, so today's topic is on reliability and statistical process control, SPC for short. Now, SPC has been around a long, long time, and it's a really nice set of tools to help us understand if something is stable. It doesn't necessarily mean that it's capable, and we'll talk about that difference a little bit more. But What we do know is that we buy a lot of products from other people and accumulate those or aggregate those into a system that we then sell or use in our factories. In either case, we have a pretty high reliance on getting good components or good parts. And SPC is just one of those tools that allows us to achieve that objective. So before I get too far ahead of myself, and I wanted to highlight that I guess it's an advertisement that we're bringing these webinars to you on behalf of or courtesy of the Ascendo Reliability site. It's right now it's in transition. We're moving to a new platform and soon to be adding podcasts on a regular basis. So hopefully you'll join me for those podcast episodes. But we'll move blogs and webinars and ebooks and the range of other activities that are over there to the new site. And so watch for upcoming announcements on when that new site's coming out. It will be ascendoreliability.com. And also I snagged I snagged the domain reliability.fm, which I'll be using for the podcast network. And so pretty excited and pretty busy trying to get all that put together. But hopefully we'll have that up this summer. So you're among the first to hear about that. So when you probably saw my note on this webinar as being on SPC, you probably are thinking, well, that's a quality topic. And in general, that's where we learn about statistical process control and process capability. We often think of factories and measuring components and parts and tracking the variability of that. In some cases, we move it further up the line. It's often associated with yield and product performance coming off the line and improving factory yield, things like that. Well, those are all very much quality topics. Now, as many of you know, the ability to make products consistently is one of those things that allows us to make a reliable product. If it's working at the end of the factory line, it's an indicator, not the only one by any means, but it is an indicator that it will continue to work over time. And the closer it is to being very capable, being well within the specifications, tends to make it a more robust product for all the various reasons that you probably already know about. So I don't really care whether we classify it as a quality tool or a reliability tool or a factory tool. The intent is that we want to make reliable parts and reliable components and reliable systems. And SPC is one of those tools that allows us to do that. So it's one of those, I don't know, crossover tools, for example. I'm not sure what the right classification would be, but it does allow us to, once we set a design, once we go through the design process and we're handing it off to the factories to assemble our product, it's one of the steps that if we don't pay attention to it, and I'm sure some of you have seen this, is that the variability from our suppliers leads to product failures in the field. And sometimes we catch it in the factory and sometimes we don't. So SPC for me is really 6 one dozen half the other, whether it's quality or reliability. It's an important tool for us to take care of in order to make a reliable system or product. So the basic idea is that we're going to have variability. Stuff varies. And that's why it matters. That's why we care about this SPC part of it. It allows us to monitor and track that variability. And there's a difference between the normal everyday, it just changes slightly from one component to the next, to the ones that drift out of spec or something that's changed dramatically. So it allows us a window into seeing what's going on. Yeah, and George, you're exactly right, is oftentimes during the development process, we take a look at creating either prototypes or our early production models, and we look at will they last over time and will they function? As you know, the the failures for end of life, the wear out mechanisms, is only one way products can fail. Another big category of the source of failures is our supply chain has too much variability. It goes out of specification. Now, it might not be enough that we notice it in production or early in the life of the product. It may take a year or more for, say, a capacitor to drift out of spec and cause failures. So if it was centered and very robustly created initially, um, then we would probably be in much better shape. Or sometimes we get a whole batch of products or components that are bad, and it leads to a significant spike in our field failures. Now, we do our utmost during production to make sure that that doesn't happen. That's not always possible. It is a difficult thing to do. And SPC and process control is one of the tools that allows us to go after controlling that source of failure or monitoring it. As you know, if you take 10 resistors off of your production facility for creating a circuit board, and they're supposed to be 100 ohms, none of them will be exactly 100 ohms if you measure them accurately. Now, they might be precision resistors and targeted to be within 1%. Well, how centered are they, and how much spread do they have? Right? So SPC and the tools that come under that umbrella is one way to monitor and track that. And the designer probably wanted a 100 ohm resistor, but acknowledged that not all of them are going to be exactly that. So what variability is acceptable and which set of variability are we getting? And, components fail. Um, Sometimes they fail right off the door, right? They just don't work right at the start. The motor or the fan doesn't spin at all when you apply voltage to it. In other cases, it may work just fine in the factory, but because of a um, because of a uh, latent defect, that's the word I'm looking for, it may fail over time. And others, just as George just put on there, is Kapoor and Lamberson, and I haven't seen that paper, I'm going to have to look for that, is that, and it intuitively, it sure makes sense to me, is that if there's a lot of variability in your supply chain or in the components itself, it's very likely that the the ability for that product to work over time is degraded. And oh, it's a textbook. All right, I'll have to track that one down and add it to my library. That looks like a good topic to keep in mind. But it certainly supports what we're talking about today, is that supplier sources of failure take all kinds of different realms. One that I'm talking about is that amount of variability. Is it stable? Is it consistent? Is it um, small enough that it meets our requirements for the product, for the element of it? And George, no worry about the interruptions. And feel everybody else, the chat window and the Q&A tabs are open the whole presentation, so please chime in. I'm going to be asking questions here in a moment, like this one. And for some reason it cut off part of my H. I'm not sure what happened there. Must be a supplier issue there. So just a quick poll, basically. Have you seen, I don't know if it's a poll or not, but let me try this other screen here to change it a little bit. Have you experienced supplier-caused failures? And were they noticeable right away, or did they take time to show up? And it gives me a second to Get a glass of water here, a sip of water. Yeah, customers complain it was bad. Yeah, George, that happens. I heard one time that these guys were having so many problems in their product production that the only time they paid attention to it was when the line was down and the VP was calling. They were plagued with so many issues. Yeah, Myron, I'm sure you have. I'm quite sure most of you have. Yeah, corrosion. Yeah, that does take time, and sometimes you need just the right mix of amount of oxygen, amount of moisture, all kinds of things to make that happen. You know, if something's not sealed correctly, corrosion can seriously be a big problem. Right. Let me bring back my so testing. So Tim, you caught it early. That's great. Yeah, lots of resources. Yeah, recall on our car. I think a few million of us have had recalls on cars for one reason or another. And sometimes they're pretty quick to point to the supplier. Think of the Takata um, airbag issue. I'd never heard of Takata before this issue, but that's not a good way to get your company in the news. Yeah, all kinds of different things. And, you know, we really rely on those components to work. And you know, I'm thinking, Myron, of a car has thousands and thousands of suppliers, and you know, we design and specify each one of those components, but we certainly aren't able to check every one of those things. And so it becomes an issue. You know that part of the design process, part of the early step that we take as reliability professionals is in making sure that there are reasonable specifications. That if we're going to specify a relay or I'm thinking of the Takata experience with their um, firing mechanism for the airbags, that it had a certain response time and a certain force that it was required to do. And it was probably specified. Um, a motor or a fan will have a certain amount of torque or airflow, and those are generally specified. And we may select components based on them meeting the application specifications. And we, as reliability engineers, we can get involved with that stage of the design process in order for components to be selected that will meet the design criteria and aren't prone to drift or aging or corrosion or all kinds of different things that can lead to failures. Now, one of the things that may or may not come up is, well, how well does the supplier actually create the components? How able are they to consistently make our products? A few weeks ago, I mentioned a poem from Oliver Wendell Holmes called The One Hoss Shay. And that's where this deacon had a carriage that failed. Uh, and so he went out and he created the, the best possible uh, uh, carriage for his one horse to pull and for his transportation. He used the best materials and made every part as strong as every other part. Now, it didn't talk about design specifications or derating or stress strength calculations or any of those other things. But this poem, written in the mid 1800s, certainly talked about that in an ideal product, we would want every part to be as strong and durable and reliable as every other part. Now, in practice, we have a hard time doing that. And so we tend to focus on the parts that we suspect will be the weakest. Sometimes we're surprised, and sometimes we're surprised because a part that we receive isn't within the specifications. And so that's where our involvement tends to go up quite a bit. Yeah, and George, you know, your comment made me think of the one Hache because everything was perfect. Now, that poem was about one carriage, one shay, as they called it then. And making more than one, I'm sure they would have run into the variability. But if you're making one, then it's possible to make it almost perfect. But that's not always capable. Now, that's part of why we set tolerances, is because we understand that there's going to be variability. And I agree that if you set really wide tolerances, that's more likely that you're going to get a combination that just isn't going to work. Now, remember back to the Motorola Six Sigma? Um, uh, oh, geez, it must be 20 years ago or more that was pretty popular. And there's still people that do Six Sigma. But the basic concept is that we want wide tolerances and very tight production performance. But the trick is getting the tolerances to actually work when you set them really large. It's not always easy. Sometimes it's downright impossible to build a product if it's at the extremes of all the tolerances, and we count on the randomness of the variability to make it work. But the other side of this, and part of what we need to know as we set tolerances, is, well, what can the suppliers actually do? So if I set a tolerance of plus or minus 2 millimeters on a crafted part, let's say a cast part, is it possible using that technology to achieve those dimensions consistently? So if they make 100 parts, what's my variability of those dimensions? And how does that compare to the tolerances? And that's what capability analysis is all about. But if we don't know what they're capable of, or what that assembly or manufacturing processes can possibly construct, we're either going to pay for it in lost yield in inspections and remove parts that are bad, or we're going to lose yield in our own assembly process, or they'll get through the process and lead to earlier or premature failures in the field, in the worst case. Now, some parts, I'm thinking of a decoupling capacitor that even if it falls off the board, the product will probably still work. The decoupling part is kind of an insurance in electronics to make sure that the signal stays true and clean and we don't have excessive radiated emissions. Yet the product will still work if it's not there. It may not work as well, but it's hard to detect. So in many cases, whether that happens or not. So even if that capacitor varied quite a bit, it has a pretty wide range despite whatever tolerance we put on it. Now that's just one example of something that is on one end of the extreme of the thousands of parts we deal with. On the other end, I think every one of you can think of one or more components that have tight tolerances and are difficult to achieve and creates problems for the product when it happens. Now, part of this process of getting involved with the design, the tolerancing system, selecting and working with suppliers, that's not generally on our job description, right? That's the design team and the supplier management team or the procurement team. Those folks tend to deal with this stuff. Now, they may or may not be dealing with the reliability aspects of this. Yet if we just simply expect that the parts will be in spec and centered and tightly controlled and stable, that may or may not be what we receive. So it's thinking through the risk reduction tools that we use, like FMEA and HALT testing and these other tools, to identify when something goes wrong, is sorting out, well, why did it go wrong? Well, part of the things we should consider is the variability from the suppliers. Now, it may be in spec, but just as George is alluding to in some of his comments, is there's some combinations and there's some variability that just leads to failures quicker than others. And then the other part is, well, do we have the tolerances correct? are we mapping this in the design from what the supplier is actually capable of doing? So this is where we get involved, because when it's not done well, it leads to product failures, and in the worst case, product failures in the field. So do you have a team? Do you get feedback from your suppliers back to your design on what they're capable of doing? Is that a part of your process? And if so, does it work? Oh, and before I forget, talking about supplier errors, many of you may have received more than one reminder about an hour ago. And if you were on the last month's or the month before's webinar, you may have received multiple thanks for attending or sorry we missed you type messages. I've been in touch with Adobe as my supplier for this service, and they say, yeah, it's a known bug, we're working on it. So I apologize, and after this session, you may receive multiple thank yous. So in part, I really am thankful that you attended and participated in the webinar, but I only intend to send you one message. So I apologize for the system and my ability to use it, sending out multiple pieces like that. So I see a few people are chiming in here. So that feedback and interaction is a regular part. So George, unfortunately, it's rare in the teams that I've gotten to work with over the past years that other than looking at your suppliers as a source of components, that the amount of information is often very lacking. Yeah, I'm more with you, Andrew, that it's not always. I see that so often. And the vendors, yeah, they've got lots and lots of customers, and you may not be buying a huge number. So it can really be a problem. What I've found is that if you illustrate to the organization, to your supply team, that if the parts are not stable and well within the tolerances, it will lead to failures. And the cost of field failures oftentimes swamps any benefit of anything else they're doing. So it's sometimes all it takes is illustrating how bad it can be. And even unfortunately, sometimes it takes having a supplier problem and then you just capture how much that actually cost you in field failures. But if you can show that proactively, it may become a regular part of your procurement organization and your design team's routine to check these assumptions, to check this data. So that's really what I'm looking for here. Yeah, and I agree with what I'm hearing here in the chat window is that oftentimes it's not common. Now, I don't suspect we're going to do it with every single component, but if you've got 1,000 components, you probably have 100 components that really could cause problems for you. So it's well worth identifying those and make it work. Yeah. So looks like you've got an opportunity to bring that function into your current role. That may be a nice thing to make it work. Yeah, and I agree. The vendor's data itself may or may not be useful. Sometimes you got to ask for it the right way, and you got to get good information. But in a worst case, you measure it yourself, especially when it's critical to the performance of your product. But those are all things that we know how to do. Now, just real quick, it's not just the vendors and their ability to manufacture products that creates variability. Yeah, I agree with you. Sometimes you just got to get the parts yourself and measure it. And that's not a trivial job a lot of times. But to cover the gamut of what we need, we do have to trust our vendor to some extent. But I agree, there's been issues sometimes. Now, our environment varies. What we suspect the customers are going to use our products and where and how. That's a guess in many cases, and it's going to vary, and that will affect the various components differently. We'll also get changes in how people use the products, right? I had a field failure from one customer when I was working at Hewlett Packard using inkjet printers on a charter fishing boat. And the printer would fail within a couple of months due to salt air corrosion, basically. And yeah, we're not going to design the product to work for that one user unless it was a big enough market to make it worthwhile. But that's an extreme. Some people use the home printers like it's a business printer, and vice versa. In each case, it changes how it can fail and how it interacts with all the various components. So it's not just the vendors that are varying. We also have environment and use variability that impacts how the components fail. And it can change how it ages, how the components themselves vary over time and age. So if a part is susceptible to corrosion because, say, a coating isn't quite thick enough, or the variability is on the low end of that scale, and the customers are using it in a harsher environment than we expect, we're going to get failures pretty quick. Now, that would be a difficult one to sort out as a supplier-caused failure. It illustrates one of the ways that the variability from our suppliers can lead to problems. Yeah, and Kirk, yeah, I totally agree with you. Is that with cell phones, for example, 10 years ago, cell phones were a treasured item and protected from all elements. Today, it's much more common to see them in back pockets and being dropped regularly. Sure, cell phones have gotten more robust, but we keep treating them more and more like a very solid, robust device that just won't fail. And then we get upset when it does fail. But the supply teams are constantly struggling to keep up with what's required from our customers and converting that back to what the suppliers are able to, what they need to know in order to provide the products we need. It's going to keep going. Our customers keep demanding more, and our suppliers keep looking at it strangely. So I apologize. I have no idea why it was cut off there. Let me change the screen here and see if it brings it up. There we go. So in your field returns, in your customer returns and your analysis of field returns, do you have a customer abuse category? Is that one of the sources or causes of failure that you bucket field returns into? You might call it something other than customer abuse, as customer damage or unintended use or some other issue. I know I've gotten this from suppliers where we send them a part and they say, well, you broke it. Like, well, yeah, we tried using it. Yeah, Myron, I agree. It does look like finger pointing. And in some cases, I've seen customer abuse being 25% of the field returns. Well, I'd say you might not quite have the design right? What we think they're supposed to be doing, they're not. And so how do you deal with that? Now, that becomes a strategic issue, but in some cases, it might be just one component. And if we go back to our supplier saying, hey, our customers are using it this way, do you have a more robust product? Now, in a more subtle case, it might be only a few percentage points where it's a variability within tolerance that leads us to this failure. There's still a lot of information in this customer abuse category. Yeah, see a bunch of agreement on this one. It's not something to bucket, we're not going to deal with that. It's something to look at as, well, Could it be a vendor supply variation? Now, if it gets run over, for example, by a bulldozer, your cell phone gets dropped under a bulldozer, well, yeah, I would say that's abuse. I don't think we're going to design a product to survive there. Yet, if that's 10 to 15% of our field failures, we need to rethink our design. Interesting. I got my lettering back there. I don't know what the deal is today with that. So how do you figure out what you're going to do? Right? I mentioned it earlier. We have way too many parts in most of our systems. Yeah, Randall, you're exactly right. The overstress is just, yeah, we don't control that. Yet I'm thinking of the example of the if you've been brave enough to watch the baggage handlers at an airport, they have a barcode reader that looks pretty robust. Now, I happen to have worked with that company that makes those things, or at least one of the types of those barcode readers for aircraft baggage handlers. And the last I knew, and this was some years ago, is they did a drop test that was, I think, 15 feet high, and I think 40 or 50 drops before they had any degradation in performance. And that was a requirement for the design. And initially, they went with some industry standard that had 10 drops from 3 feet onto concrete, and found that they had lots and lots of field failures due to dropping. Now, if you've ever watched the baggage handlers, they drop that barcode reader more often than bags. And some of them even have it tethered, but they're still banging it into the gantries and vehicles they're doing and so on. So it's a part of how products get used that then translates all the way back to our suppliers, and it's going to be an ongoing dance with our suppliers to get robust, solid parts. Now, controlling the variability is a part of that process. But we have so many suppliers and so many parts, we're not going to be able to do that for everything. So we could just ask for control charts on everything. Now, the trick is, well, what exactly do you want to control? Which of the many dimensions, even on a simple resistor, do you want to ask for control on? And do you even have the bandwidth to monitor all of that on every part in your system? Probably not. So let's narrow that down a little bit. So one aspect, and one that served me well over time, is, well, what have you seen in development? What have you seen in your prototypes? What were the supplier-based variability that occurred that said, hey, this isn't right. We still want to use this vendor. It's the right component, but we want to improve our process by controlling and stabilizing the source of this part. Now, in one case, I had a crystal, a small metal can surface mount crystal that was used on an electronics board. And they're very, very common. There's a crystal or some kind of timing component on just about any digital circuit board. And the process of attaching the actual crystal element to the leads within that can was variable. The amount of the little bit of silver epoxy that attached the crystal to the lead. And if they only went about halfway across, that crystal was very susceptible to cracking with even a modest amount of vibration. Now, unfortunately, this product was a handheld, and it was a game controller, and so it was likely to be dropped, and with just a few drops, that crystal would crack if that epoxy was not all the way across as the specification required from the manufacturer's site. Now, we saw that in a prototype. We had, I don't know, maybe 20 or 30 prototypes, and one of them failed. So 1 out of 20, that's easy to dismiss. That's a one-time event, shouldn't be a big deal. But that also represents a 5% field failure. So we investigated it. And we opened up about 100 of these little cans looking at the epoxy and noticed quite a bit of variability. And So we went back to that vendor and asked them to monitor and help them install a device to check the deposit of that epoxy. Now, it made all of their products better for all of our competitors and for all of the people that were using their components, but it solved a problem for us for our application. And it was worth the effort given the potential to, say, a 5% or a variable amount of failures in the field. So sometimes our systems and the way we develop products and we do early testing and so on alerts us to where the suppliers are contributing to problems. And then taking steps to implement that helps us make that work. Sometimes we get those signals. Sometimes we get the indication. And sometimes it's from our experience and our team's experience. So FMEAs, it's a great way to explore, well, what could the supplier's variability what kind of variability could happen that would lead to failures, and what should we monitor and check? And so let's prioritize that to the ones that are most likely to vary and cause problems. All right. Well, in your experience, what have you seen that has triggered you working with suppliers to improve, or I should say, not improve, but minimize the amount of variability they do, they provide or cause to happen? Give you a second there to make sure your keyboard's working. I was working with a medical device company a couple months ago, and they were getting these EDM, which I don't remember what that stands for, cut, and it wasn't titanium, it was some very exotic cut of steel or grade of steel. And the process itself, it was optimized as much as they possibly could. These things were made by craftsmen. Yet it was about twice the amount of variability that allowed the stack of components to actually work. So using the best possible technology with the best craftsmen that understood the issues, they were still not capable. Now that was kind of an extreme, and they were going to great lengths to try to figure out how to design a product that would accommodate the amount of variability they were getting in these components. But at least they knew about it. That's part of the trick. Yeah, incoming inspection failures, first article inspections. Yeah, Andrew, that's a great point. With the change notifications, um, I know that a few times we've been burned with they moved facilities to a new country and didn't tell us, thinking it wouldn't make a difference, and the variability spiked. Um, but other cases, they will tell us that we have to update this material or change this process. But all too often, it's a judgment call as to whether we uh, do an investigation or check to see if that amount of variability has changed or not. But those are all good things to take a look at. All right, so let's take a look at, well, how do you spot a good program? You know, if you work with vendors or you're working with your procurement team that's auditing vendors, uh, hopefully you're not just saying, hey, make good parts, make them in spec, make them tight and capable, in control, and then don't monitor it. If your process is only looking at defects or problems or issues, and the only time you go get involved with a vendor is when there's an issue, I suggest that there's an opportunity there to get ahead of the game a little bit. So if I and I'm sure you've got plenty of stories like I do of, well, the vendors only doing what you're asking for. So they're cost reducing, they're cost reducing, they're cost reducing. And the quality and the stability of the product continues to erode. And then you have a problem with them when products start to fail. And they're like, hey, you never talked about that. You just wanted this part cheaper and cheaper and cheaper. If you don't measure and monitor and involve your vendors with what you really want, which includes that it's a good part, the likelihood of getting good parts is eroded. And I think this is pretty obvious. But all too often we just say, hey, make good parts, do SPC, and then we never look at it again. So, I mean, we're doing this so that we can get good information and good parts to make good decisions. The SPC process allows us to get a lot of information. Now, as we're working with suppliers and as we notice issues, even when we notice issues, I should say, it's not you're bad supplier, bad supplier. It's not blaming them. It's, well, let's get the information and what's possible. Are our tolerances and expectations too tight for this technology? Is there some other element that we need to consider? Is how can we work together based on the information that we can gather to get a good part, a good process, and get a good system put together? This can be difficult, and I've seen it in procurement teams way too often, is they'll put the vendors onto the defensive when they really don't need to. What we need is a solution. And when we work together, we're often much more likely to find a solution. So let's spin this around a little bit. Yeah, you're exactly right. Vendors need to make money, right? But they can help us and help themselves if they understand what's critical, what's important. Now, even on a very, very simple, like a resistor, there's a bunch of different dimensions. And if for whatever reason our particular application, the height of the resistor is critical for it to fit within our, say, a cell phone, well, we need to let them know. But if the only thing we ever mention is the resistance value, then they'll pay attention to the resistance value and ignore the height. And one way to improve the consistency of resistance may be to allow the height to vary more than we would expect. So part of it is we have to communicate what's critical to the performance of our product and to the consistent realm of our product. Now, our first set of communication is the tolerancing. And especially with custom parts, we're usually pretty good about that. But then it's make sure you measure it and talk to them about what's good and what's not good. If we insist that they do control charting and gather data and analyzing what's our process capability, well then, what's in it for them? One is continued business, but they may know and we may know that we don't have a lot of options for this particular component or part. So we're going to get what we get. But if we involve them in that profitability type idea that you just mentioned, then if they're stable and capable, well within the tolerances, and are actually doing control chart process on the things that matter, well, let's share some of the benefit with them. Instead of just to buy a part and give them $1 for that part, give them $1.10 for 6 months worth of good parts, because in the long run, it really does save us a lot of money compared to the cost of field failures. Yeah. Andrew, it's interesting you mentioned that, and I expected to hear that at some point, is that, yeah, when I worked at HP, we had huge leverage on buying power because we just bought so many components from electronics suppliers. What I have found with smaller companies is that the smaller company often represents a much higher profit margin for the suppliers. Just remind them that, yeah, we're paying more and we expect better parts. We expect some response. We expect other elements of this thing. Smaller suppliers oftentimes have more options, then like at HP at one time they were buying a third of the world's capacitors. Um, so with HP had to buy parts from whoever they could find that made the parts. Whereas a smaller group, yes, you pay more. I think that should come with that you should get more. And part of that is being clear about what you want. Part of it is encouraging them with money, for example, or information, or training, or whatever, to help them create better parts themselves for us and for other customers. So in many cases, it may involve teaching and working with your suppliers in order for you to get the best possible components. Now, that medical device company has spent a lot of time with the folks with the teams that were crafting these components for them and cutting these components. Now, they've made a lot of improvement, and it improved their entire shop's capability. It's still got some ways to go, yet in some cases, that's just what you got to do. And the difference between getting a control chart that's just run up once a month and nobody actually uses it versus the ones that are actually being used on the production line to monitor and control the production is pretty obvious for most of us to see. And I don't know how many factories I've been in where the control chart is behind glass in the visitors area and there's not any on the production floor. Well, in my mind, that's not really control charts. That's not really useful. And if the data being collected is pretty random, has high measurement error, isn't treated as important information that it actually is, that supplier, it's easy to blame them for not paying attention or caring. But let's talk to them about why we're asking for that, why it's important to our production and to our customers. And if they're a reputable supplier, they may just need the awareness and a bit of information to do a good job. And like you, I've run into many, many different engineers across industries, and they generally, to the person, want to do a good job. And sometimes they just need a little information and encouragement to make that happen. Yeah. Thanks for the support, Alex. I appreciate that. The bottom line is, do you treat your suppliers as partners or as adversaries? And one of the arguments I've heard too many times is, well, if we help that supplier, it helps all of our competitors. Well, yeah, but we need the parts. We need good parts. We're the one that pays for failures when they occur. So if it's not worth $10K for us to help that supplier to avoid $100,000 in field failures, then why are we in business? Right? Let's think through this with the concept of avoiding customer failures and customer complaints. And once you connect it to that, all the way back to your suppliers, these arguments tend to fall away. Not always, but it can help. All right. So I think I'm coming up right to the end of this thing. Take a look at a couple of comments here. I pulled up this banner because it's a podcast that I'm hoping to have up on that new Ascendo site here in the next month or so. It's a series of interviews with quality and reliability thought leaders. So just a quick note to take a look for that as it comes out. So SBC is just one of those tools. It might be called a quality tool, but it's certainly something that we need to get involved with because it can help avoid those variability of components related field failures. And it has lots of other benefits too, but there's our hook for being involved as a reliability engineer. So let me catch up with some of the comments here. Yeah, Randall, it does take some work, and for critical parts and for critical suppliers, we may want to work with them on their site. We may want to repeat the measurements with a separate system to really, really make sure. Yet the difference between we're doing SPC because suppliers ask for it but don't really use it, and actually using SPC is a pretty dramatic difference. And the teams that actually use it to see that they get benefit from it, generally it's pretty obvious, and I would trust their data, especially if it's not the most critical piece on our system. And it's going to vary. Every part and product is going to vary. Yet it's not an excuse not to use the tool, though. Is that we need good data? Yes. Are we going to get good data all the time? No. But are we going to get bad parts if we don't ask for data? Most likely. So yes, we've got to ask for stable processes that are capable of making the parts we need. And getting the data is the only way I know of to make that happen. And yes, it will take some work. Yeah, Alex, and you commented on multiple sources. Many times that's possible, and it's a bit of insurance for all kinds of procurement-related risks. In some cases, we just don't have that option. But either way, it doesn't mean that we're going to get good parts just because we have two suppliers. We still need to monitor and manage the ones that are critical to the performance of our product. All right, let me bring up the links, and if you wanted to get a hold of the slides, they're in the download section to the right, and there's some links. Feel free to connect with me on LinkedIn or Twitter. All those kinds of stuff are up here. And I'll stay online here for a few more minutes, taking a look at any questions or comments. But I think that wasn't a dramatic conclusion to my presentation here. I didn't, in hindsight, I didn't think through how a summary would be really effective right there, but I think that's all I got. SPC is a tool, and it's one that we can use to great effect when used well for the purpose of improving our product reliability. So hopefully you see that connection and see a couple of ways that you can help make that happen within your organization. And thanks to everybody I see a lot of familiar names, so I appreciate everybody that's come back again. Let your friends and neighbors know. If it's useful for you, maybe it's useful for them. More the merrier as it goes. All right, appreciate it, everybody. Thank you. And I'll let you get on with the rest of your Tuesday. I suspect it's Tuesday for most everybody. If you're listening to the recording, let me know what questions you have. I would appreciate hearing from you also. And for the folks that are still online, take a look at the Ascendo reliability site. We've got almost over a year's worth of recorded webinars. So if this is one of your first ones, there's a bunch of previous ones similar in nature, a range of different topics that are out there, and they're free.